Thank you, Dragan, and thank you all for coming. I guess that we all know each other, at least from the, we met each other and on the department. So it's really nice to see you today at this workshop. I'm going to talk about climate and bioclimate conditions and trends in Serbia. What is important that I'm going to show here is actually the results that we got from these reports that you also can find online. And some of the results might sound surprising to you, but I will show you everything in detail. So, what is the background? So, climate of Serbia, it's a moderate continental, and it has more or less pronounced these local characteristics. Some of the influences that affect this climate are geographic location, relief, local influences, and so on. Also, the urbanization lately is also very the thing that affects especially climate in the cities the most. We also have some synoptic situations from much wider scale that also affects climate in Serbia, and it's the Alps, Mediterranean Sea, Pannonian Plain, the Valley of Morava, and Carpathian and Rhodope Mountains. According to Köppen climate classification, the most distributed climate is CFB, so it's continental with moderately humid climate, and also it has some of the other variations, but CFB is the most dominant. You can see the map here. It is in Serbian because it is downloaded from Republic Hydrometeorological Service, and it shows some of the stations that are used for measuring climate data. What I wanted to show also as a background is the temperature changes of Republic of Serbia since 1901. So what is important here to see, those are so-called climate stripes. Have you ever heard of something like this? I guess you did, because they're becoming very popular. You can also see them on the COVID masks, on some billboards, some newspapers and everything, because they're showing climate change on a very, very simple way. Each of these stripes actually shows the higher or lower temperature in reference with the average temperature in the Republic of Serbia. And as you can see, when we go to the 2000s, we can see that most of the time we have higher than average temperatures in our country. The more dark the lines are, that means that these higher temperatures are more pronounced. Here we have another graph that might be a bit more clear, and you can see that this reference period for the average temperature is taken from 1971 to 2000, and as we can see in the last 2 decades, almost every year has average temperature that is higher than this reference period. So these hot summers in Serbia, as you might also notice, has more intensive heat waves that are becoming more frequent also. At the beginning of this century, we had 2 or 3 heat waves per year, but per summer. But now we have also 4 or 5 heat waves that last longer, and we can also observe them in May, but also in September. And before, we mostly notice the heat waves in July or August, which are the hottest months in our country. So we have this limited number of studies that investigated what actually that heat does to our health, and we are trying to fill that gap. So we are here investigating, actually giving the overview of the most common parameters for climate investigation: temperature, humidity, wind, and cloudiness in Serbia. And those 4 are taken for purpose actually on purpose, because we wanted to calculate thermal comfort, and these parameters is what we needed to do that. So we will, because we have a lot of stations, as Dragan mentions, 47 stations, so for 47 cities. And we used only the data provided from Republic Hydrometeorological Service, because they have the wider measurement network, so their data are actually what we need for in order to investigate the climate in Serbia. So we use their data, but we cannot present it today because it would last until the late afternoon. We will present only the 3 biggest cities in Serbia: Belgrade, Novi Sad, and Niš. And those are the cities where majority of population lives, and we will focus on annual period and summer periods. So here we will start with temperature changes in the last 2 decades, and we have this data from 47 official stations in Serbia. And we can see that the line goes up and down each year. But what is very important that we see in Belgrade and in Niš, this is the average for each year. We can see that the trend line, this blue line, goes up, and it goes in Niš and in Belgrade. We can say that it goes from approximately 0.5 per decade. The temperature goes, average yearly temperature goes up, and also in Niš it is even more pronounced, and it goes from 0.7 per decade. Okay, okay, never mind. The photos go over the text, but it's okay. So for humidity, we were considering relative humidity, because that is the humidity that is recorded by Republic Hydrometeorological Service. And it is really tricky to catch the trend for relative humidity, because it is very, its dynamics is very pronounced. But we also can see that in Novi Sad, changes in relative humidity are like that. In the trend line, we can see that the relative humidity grows slowly, but it does. And in Niš, we can see the opposite direction, that the relative humidity drops. Those percentage, it is the average data, and those percentage are very small, but relative humidity is very related to air temperature, but also it has some of the other things that affects her, so it is a bit tricky to explain. Cloud changes in Serbia, as we can see, is also shows both increase and decrease in the yearly level, and the trend line also goes in Belgrade, it goes down, but in Novi Sad it goes up. This is something that we cannot include in climate change, but this cloud cover is very important in calculating the thermal comfort indices, but not very important in terms of influence on the temperature and other climate parameters. Also, wind speed is it's not very high on average in southern Serbia, but it is a bit more pronounced in the northern Serbia. Also, it has high variability. Now that we presented these main climate conditions in Serbia, we can go to bioclimatic conditions. What we want to explain here is what is the real feel of the human when we go out, because we usually can see on the weather forecast that we are 22 degrees it's outside, but when you go out, then you can see that you are feeling much more hot or much more cold than what it said in the weather forecast. That is because most of the the air temperature is not the only parameter that affects our thermal comfort. There are many other things that affect it, and among others, the four parameters that I showed before also affect thermal comfort of humans. So what is biometeorology? According to International Society of Biometeorology, it is interdisciplinary science that considers how weather and climate impacts well-being of all living creatures, not just humans, but also plants and animals. But of course, here we are only dealing with human biometeorology, and that is a part of biometeorology that deals with the influence of the weather on and the climate on human life and health. When it comes to biometeorology, cities are the main focus for the researchers, and also it is very important for the people, because since 2007, more than 50% of the world population lives in cities. That is why it is actually justified to have cities as the focus of biometeorological research. In Serbia, also, Republic Hydrometeorological Service provides daily information on biometeorology. As you may also notice in some newspapers or anything, you have this map of Serbia with smiley faces on it. If biometeorological conditions are good, then you have the smiling face. If they're not that good, then the face is sad. What does it mean? It means that some of these biometeorological conditions are affecting our mood, our level of energy, and it serves the purpose of this biometeorological forecast. It is that when people are suffering from some illness or have some difficulties with their health, can choose whether to do some more demanding, physically demanding activities in that day, or maybe do some lighter things that day. That is the purpose why Hydrometeorological Service is actually publishing this data in that way. What is also important with biometeorological conditions, other than public health, it is also very important for urban design and planning, because as I already said, we are here actually taking into account only meteorological conditions for thermal comfort, but in the broader context, we have noticed that urbanization has very important effect on human health, and also on thermal conditions and thermal comfort of humans. So what is thermal comfort? Thermal comfort is actually how do we feel in the day. This picture is kind of funny, but it is very good for explanation what actually thermal comfort is. You see this yellow guy, he is perfectly okay. He's smiling, he is happy, but when you have conditions that you are feeling a bit chilly or a bit warm, then you see those faces are not really smiling. When you have some extremes, you can see this guy is blowing his mind, you know, so it's very hot. And this guy on the other side, on the left side, is freezing. He cannot do anything. He's just frozen. So how do we actually calculate and how do we present this thermal comfort? We do that by calculating thermal comfort indices. These indices we can split in three categories. So we have thermal indices that are based on human energy balance, and they are also interrelated with metabolic activities of one person. They also take into consideration clothing and also environmental parameters. When we are talking about empirical indices, then we are actually having these linear regressions that are based on the field studies. So empirical indices are taking into consideration empirical studies. So they are usually using monitorings and survey for calculation. And we also have indices based on linear equations that also are taking thermal environment, and but they are neglecting human behavior. Today, we will present two thermal indices that are PET and UTCI and they're calculated through a software, and we are presenting one index that is based on linear equations, so it doesn't take into account this broader context. We use data from official weather station of Serbia from 2000 to 2020 to calculate these three indices that I already mentioned. The software that calculates PET and UTCI index is called Raman. It's very simple, and it also has some of the aspects of the environment and some of the aspects of clothing already installed as a default value in the software. Also, it takes into account human height, human weight. That is also a default measure in this software, but you can change it. We here took the default measures that are, I think, male from 1 meter 75 centimeters tall and around 8-ish kilograms, right? Yeah, it's Dragan actually. We calculated these indexes according to Dragan's height and size. So then we calculated these indexes, but for Humidex, as we said, it is based on some linear equation. We took the equation, and some of our colleagues were very kind to provide this equation transformed to Excel, so we could very easily calculate it with this formula. I didn't set the formula here because I don't think you need it, but if you need, you can contact me, Dragan, Daniela, whoever we will give you. We focused on the 3 largest cities with the majority of population of Serbia, and this is where we can see what I said, that that's a bit of a strange situation, but because we are talking extreme heat in Serbia. Here we will show you the PET changes in Serbia. At the very bottom, you can see the scale. Here you can see the thresholds for these results. So we did it for 26 stations in Serbia. What happened with the rest of the stations? It happened that some of the data were missing. When we miss some of the data, for example, for the wind or for the cloudiness, then we cannot calculate. If we miss some of the parameter, we cannot calculate our index. So we left with the 26 stations that had the complete data. So substantial PIT values increase in the past 2 decades. So we can see that the trend line is going up. We can also see that there are some of the there is some dynamics in these lines, and that vary from year to year. We can see in the 2004 and 5 it is a bit there is a bit lower temperatures, but then they go up. What we can see here, we can see that there is no thermal stress, no hot thermal stress, but there is slight cold stress. But you can always remember that we here used the data averaged per year. So we averaged the data for each year. We took the coldest months and the hottest months, actually every month in the year, and then make the average. According to that average, we are having a slightly cold stress on average, but that is not the case. The average data means nothing to us. What we can see here, and what is the most important, is that this trend line goes up. That means that this average data will actually go up in the future too. This is the case for Belgrade, this is the case for Niš too. What happens in summer? When summer months, in this case, July and August, we had that most of the time in summer months, we had moderate heat stress. What does it mean? That the PET values were between 29 and 35 degrees. Here we have moderate heat stress. And what does it mean? That our thermal sensation is warm. We actually had some years, 2007, 12, 2013 and 16, that goes into strong heat stress. And this is also average data for the month. This is not the 1 day. So we had days with lower and with higher temperature. And when we say that on average we have a strong heat stress, then you can imagine that some of the days we felt like this guy totally on the right side, so burning out. And the data for these data were also recorded for Belgrade and for Niš. UTCI, the other index. Let's see what other index says, just to make sure that this is the right thing that we are doing. So we also analyzed the 26 station because we needed these 4 parameters from the beginning of the presentation. And what we noticed is also that there is almost no heat stress on average when we take the yearly data. But we can also see that in Novi Sad, the trend lines goes up, but very, very slightly. But in Belgrade, we can see that this line is very much more pronounced. So we can expect these yearly values to go up. So according to the UTCI scale, we see that there is no thermal stress on yearly average. But what happens in summer also? In summer, we can say that there is moderate heat stress in Belgrade. These are August month for Belgrade and for Niš. And we can see that these lines are much more pronounced than what we had for yearly average. Also, we can see that there were years with heat stress on average above 30 degrees, which means that it goes from moderate to strong heat stress. This is especially the case in the last 2 or 3 years for Belgrade. For Niš, the situation is a bit different, but in Niš, as we can see here, the lowest grade is 25, and in Niš it's 28. So we can say that in Niš, the temperatures, on average, summer temperatures are much higher. Also, we can say that above 32 degrees in Niš, we have more years that go into strong heat stress. So the humidex. Humidex is another index that is also calculated, but it neglects all the other things. So metabolic rates, the height, the clothing, what do we say? Yeah, the clothing. This index we didn't include in calculation of the humidex. It bases mostly on temperature and relative humidity. So what does it say in for average yearly data? It says that there is no heat stress, actually no discomfort. That is what we call it when we are looking at the humidex. There is no discomfort in Novi Sad nor in Niš, but we see the trend lines are going up like in the previous 2 indexes. For July and August, it really is, I don't know why did this graphs go over the text, but whatever. When we are looking at the summer months, for example, in July in Novi Sad, we can see some discomfort, but only in 2012. So it's over 30. We see here it is some discomfort. Less than 29, we can say that there is no discomfort. When we're talking about Belgrade, then we see that some of the there is more years in this area, 30 to 39 degrees. So it shows also some discomfort. So what we can say, and why did I say at the beginning of this presentation that you might be surprised? You might be surprised because we are showing here that on the yearly level, we do not notice some great discomfort, some great heat stress. But that is only because we are looking at the average data. When we are looking on the average data on one hot month, July or August, we almost always see discomfort. What we also see that all the 3 of indexes that we included, all 3 of them are showing some discomfort. Also, UTCI show the least discomfort, but we always have to remember that it also only includes air temperature and relative humidity and neglects all the other aspects that are influencing thermal comfort. The other thing that I wanted to mention here, we are using the data from Republic Hydrometeorological Service, and their stations are often out of the town, so out of the cities. So, and also what is important, there we are having the data on at 7 o'clock a.m. we have 2 p.m. and 9 p.m. So, and sometimes the data are missing. So here we have this opportunity to fill that gap, which we are doing most of the time. probably saw us measuring with our little instruments around the town. So this is the way to fill the gap that we are having with this data from official weather services. So my colleague Daniela will talk more about this influence of the heat stress on the health of the people. But in general, we show that here very general information, but we could notice some trends that the temperatures are going to be more pronounced in the future, and that thermal comfort will be probably lowered in the summer months. As Dragan said, you can find in our website these reports, but also I want to announce that it will be one paper that we are working on right now, and where we will show more detailed information about this extreme heat in Serbia, also based on this data that we have from Republic Hydrometeorological Service. And these are also links for our social media. So I invite you to follow us and maybe to, you know, see what are we doing. And if you're interested to take some information or to ask for something, please do that.